Hello students, welcome back to the session. In this session, let us try to understand the meaning of EMF and terminal potential difference of a cell. We are going to discuss about EMF, that is called electromotive force, and terminal potential difference of a device called what it is? Cell. So let us try to understand what is the meaning of cell here. What is the meaning of cell? Cell is called energy source. Which energy source? The cell is called electrical energy source. How the cell can be defined in physics? Cell is a device which is used to draw the constant current to the circuit. The function of the cell is to provide the constant current to what? External circuit. Let us consider a simple circuit here. Conducting wire of a certain resistance R, the conducting wire of certain resistance R is connected across a device called what? Cell. So this is the circuit symbol of the cell here. This is the circuit symbol of a given cell here. The big line corresponds to positive terminal of a cell and a small line corresponds to what? Negative terminal of a cell. This is the circuit symbol of the cell. The cell is connected across a wire or a conducting wire of a certain resistance R. When the cell is connected across a conducting wire or cell is connected across what? The wire of certain resistance R. What happens? The current starts flowing through the circuit. The current starts flowing through the circuit. That current which is flowing through a conductor or current which is flowing through a conducting wire is constant here. That constant current is provided by the device called what? Cell here. Therefore, how you are going to define cell here? Cell is a device or cell is a energy source. Cell is a energy source which will provide the constant current to the circuit. This is called external circuit. The required current which is flowing through a circuit is provided by what? The cell here. In a simple way, the cell can be defined as it is a device which is used to draw the constant current. Cell is a device which is used to draw the constant current. Let us write the definition of the cell in the first step. How you are going to define cell? Cell is a device. Cell is a device used to draw constant current. Wherever you are in need of what? The constant current. ಎಲ್ಲೆಲ್ಲಿ ನಿಮಗೆ constant current ಬೇಕಿದೆ ಆ ಎಲ್ಲ ಸಿಚುವೇಶನ್ ನಲ್ಲಿ we are making use of the device called what it is? Cell here. So repeatedly we are using the two important terms in the what? Electricity. One is cell is used in a closed circuit. The cell is used in what? Open circuit. What is the difference between cell is in closed circuit and a cell is in open circuit? What is the meaning of cell is in closed circuit and a cell is in open circuit? Suppose if you draw the current from the cell, ಸೆಲ್ ಇಂದ ಒಂದ್ ವೇಳೆ ಕರೆಂಟ್ ನ ಡ್ರಾ ಮಾಡಿದ್ರೆ, ನೀವು ಒಂದ್ ವೇಳೆ ಸೆಲ್ ಇಂದ ಕರೆಂಟ್ ನ ತಗೊಂಡ್ರೆ, then the cell is said to be in which circuit? Closed circuit. Concentrate on the sentence here. Cell is said to be in closed circuit provided you have to draw the current from the cell. Say for example, I have a conducting wire of resistance R. Say for example, it may be a nichrome wire, or it may be a manganese wire, or it may be a copper wire, aluminium wire, whatever the wire it may be. This wire, conducting wire, has a certain resistance R. Suppose the two ends of the wire are connected to the cell. ಈ wire ನ ಒಂದ್ ವೇಳೆ cell ಗೆ connect ಮಾಡಿದ್ರೆ, now what I can say? cell is in closed circuit. Now I am using the term the cell is in closed circuit. Why the cell is in closed circuit? Because you have drawn the current from the cell. One ವೇಳೆ ಸೆಲ್ಲಿನ ಈ ರೆಜಿಸ್ಟರ್ ಅಥವಾ ಕಂಡಕ್ಟಿಂಗ್ ವೈರ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ದ ಕರೆಂಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ವಾಟ್ flowing through the circuit, or current is supplied by the cell to the circuit. Now I am using the term the cell is in closed circuit. Now what I can say, this cell is in which circuit? Closed circuit. This cell is in closed circuit. Try to understand, when does the cell is said to be in closed circuit? Cell is said to be in closed circuit when you are drawing or taking the current from the cell. Current na ತಗೊಂಡ್ರೆ ಸೆಲ್ ಇಂದ ಎಕ್ಸ್ಟರ್ನಲ್ ಸರ್ಕ್ಯೂಟ್ ಗೆ ಕರೆಂಟ್ ಸಪ್ಲೈ ಆಯಿತು ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ we are using the term the cell is in closed circuit. Suppose the cell is kept as it is. Suppose the cell is kept as it is. This is the positive terminal of a cell and this is the what negative terminal of a cell. Cell in ತಗೊಂಡು as it is ಇಟ್ಬಿಟ್ರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Definitely the no current is drawn from the cell because cell is not at all connected across what any device here, any conductor. Cell ನ ಯಾವುದು ಡಿವೈಸ್ ಗೂ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ, ನೀವು ಯಾವುದು ಕಂಡಕ್ಟರ್ ಕನೆಕ್ಟ್ ಮಾಡಿಲ್ಲ. Definitely now the cell is not at all going to supply any current, or else you are not drawing any current from the cell here. When the cell is kept as it is without drawing any current from the cell, now the cell is in which circuit? The cell is in open circuit. Try to understand the difference. Suppose if you are drawing the current from the cell in the current na ತಗೊಂಡ್ರೆ definitely the cell is said to be in which circuit? Closed circuit. Suppose the cell is kept as it is without drawing any current from the cell, then the cell is said to be in what? Open circuit. See, for example, this is the pencil cell. Of course, this is the cell here. One of its terminal is called positive terminal, another terminal is called negative terminal. Suppose if you keep the cell as it is, suppose if you keep this cell as it is, ಈ cell ನ ಹಿಂಗೆ ಬಿಟ್ಟಿರತ್ತಂದ್ರೆ now the cell is said to be in which circuit? Open circuit. Why the cell is said to be in open circuit? Because no current is drawn from this cell. ಈ cell ಇಂದ ಯಾವುದು ಕರೆಂಟ್ ನ ಡ್ರಾ ಮಾಡಿಲ್ಲ, ನೀವು ತಗೊಂಡಿಲ್ಲ. That's what the cell is said to be in which circuit? Open circuit. Suppose the two ends of any conducting wire. Suppose the two ends of any conducting wire is connected across a cell. ಈ ಸೆಲ್ಲಿಗೆ ವೈರ್ ಎರಡು ಎಂಡ್ ಏನಾದರೂ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. ಸಪೋಸ್ ಯು ಹ್ಯಾವ್ ಕನೆಕ್ಟೆಡ್ ಟೂ ಎಂಡ್ಸ್ ಆಫ್ ಎನಿ ವೈರ್ ಅಕ್ರಾಸ್ ದಿಸ್ ಸೆಲ್. As a result, what happens? Through this wire, the current starts flowing. Definitely through this wire, the current starts flowing. Now the cell is said to be in which circuit? The cell is said to be in closed circuit. Now this cell is said to be in closed circuit. Simple sense nalli helbekandre, take a cell of around 3 volt voltage, connect a small bulb across a cell, small LED bulb across a cell. Definitely that bulb will start glowing. Now I can say the cell is supplied a current through what? Current to what? That bulb. That's what the bulb is glowing. Now the cell is said to be in which circuit? Closed circuit. Suppose if we keep cell as it is, then the cell is said to be in what? Open circuit. So simple way nalli helbekadre, if current is drawn from the cell, then the cell is said to be in closed circuit. Suppose no current is drawn from the cell, then the cell is said to be in which circuit it is? It is in open circuit. Let us now determine potential difference across a cell when it is in open circuit. ಒಂದು ಸೆಲ್ ತಗೊಂಡು across that cell you measure a potential difference when the cell is in open circuit. Open circuit nalli cell iddaga across the cell you measure a potential difference with help of what? Voltmeter. Whatever the potential difference we are measuring, across a cell when it is in which circuit? Open circuit. Such a potential difference, we'll call it as a EMF. What is EMF? Electromotive force. What is electromotive force? It is a potential difference or it is a voltage across a cell when it is in which circuit? Open circuit. Concentrate here. Potential difference across a cell. Potential difference across a cell in which circuit? Open circuit. The potential difference across a cell in open circuit is called what? EMF of a cell here. That EMF is also called electromotive force. Now the cell is in which circuit? Open circuit. Already the cell is labeled with what? 1.5 here. What is 1.5? The 1.5 is a potential difference or voltage across a cell when it is in which circuit? Open circuit. Then definitely that voltage or potential difference across a cell when it is in what? Open circuit, we will call it as a what? EMF of a cell. Okay. Suppose same cell you connect across a circuit. Say for example, I have conducting wire of resistance R. Across this wire I am connecting a cell. Now the cell is in what? Now the cell is in closed circuit. Once again you measure potential difference or voltage across a cell when it is in which circuit? Closed circuit. This voltage will be less than voltage what you measured when the cell is in what? Open circuit. If for example either the 1.5 voltage. What is 1.5 volt? You tell me. It is a potential difference across a cell or voltage across a cell when it is in which circuit? Open circuit. ಇದೇ ಸೆಲ್ ನ ಒಂದ್ ವೇಳೆ ಯಾವ್ದಾದ್ರೂ ವೈರಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಕಂಡಕ್ಟಿಂಗ್ ವೈರ್ಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿ ಮತ್ತೊಂದು ಸರ್ತಿ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ನ ಮೆಜರ್ ಮಾಡಿ. Definitely that potential difference will be less than 1.5. ಮೊದಲಿನ 1.5 ಅದಲ್ಲ, definitely it will be less than 1.5. That potential difference, we will call it as a terminal potential difference of a cell. What is terminal potential difference of a cell? The terminal potential difference of a cell is potential difference across a cell when it is in which circuit? Closed circuit. Potential difference across a cell in which circuit? Closed circuit is called terminal potential difference. So this is the difference between what? EMF of a cell and potential difference of a cell. I will let you know the difference between EMF and terminal potential difference in very simple way. It is, take a cell. The device which is used to measure potential difference is called what? Voltmeter. The device which is used to measure the potential difference, we will call it as a voltmeter. Take a cell. Now the cell is in what? Which circuit? Open circuit. Measure the voltage across a cell with the help of what? Voltmeter when the cell is in which circuit? Open circuit. Whatever the voltage you are getting or whatever the voltage read by the voltmeter, that voltage we will call it as a what? Potential difference across a cell in open circuit. That voltage or that potential difference we will call it as a EMF of a cell. Suppose same cell is connected across one wire. take a wire or small bulb you can consider. Same cell which is connected across a what? The wire. Say for example, this is the wire. Across this wire, this cell is connected. This cell is connected across a wire. Now you measure the voltage or potential difference across this cell. Now you measure potential difference or voltage across this cell. Now it is called potential difference across a cell in which circuit? Closed circuit. This potential difference, we will call it as a terminal potential difference. Generally, the terminal potential difference is called V. EMF is called what? E. Terminal potential difference will be less than what? EMF. In any electronic circuit, you consider the terminal potential difference will be less than what? EMF, or EMF will be generally greater as compared to what? Terminal potential difference. In the next session, I will explain the more about what? Terminal potential difference by taking an example of what? Simple circuit. Okay.